Today I'm going to talk to you about the difference between solids, liquids, and gases. Solids, as you may have learned in the past, will maintain their shape. Another word for maintain is constant shape. Liquids, however, will take the shape of their container, while gases will also take the shape of their container. Solids have a constant volume. Liquids also have a constant volume. Gases, on the other hand, will take up the volume of the entire container. The way to think of constant is to think of the word regardless of the container. So if it has a constant shape or maintains its shape, you could have a Texas-shaped container, but if you have an ice cube that's a cube, it's going to still be a cube. Whereas if you had a Texas-shaped ice cube and you put it in a glass, it's going to still be a Texas-shaped ice cube. Whereas water, if you pour it in a Texas-shaped container, it'll be Texas-shaped, but you pour it in a round container, it'll turn into the round shape. And gases will do the same thing. They'll take the shape of their container. Okay, we'll draw some pictures here in a minute, and I hope it'll make a little more sense. We normally talk about particles and their temperature, cold, warm, or hot, but what we really are talking about is the motion of the particles. Temperature is in measurement of the average kinetic energy of a particle. And you may remember from IPC that kinetic energy is the energy created by a particle's motion. So if it has small particle motion, it's going to have a lower temperature. Okay? So all solids, the particles are actually moving. They're vibrating back and forth so fast and so small we can't see it, but they do vibrate back and forth. That's why it's a solid. Okay? But they're still connected. There's enough forces between the molecules and atoms that they're not just going to go flying apart. As we heat up the solid, as we heat it up, basically what we're doing is we're speeding up the particles, speeding them up, and the particles are moving faster. When they move fast enough, those particles are able to move freely. That's why water flows, because those molecules are able to move around. They have enough energy, they can move. So it's enough energy that it can spread out to fill the container, but it's not enough energy for it to suddenly grow in the container. It still maintains a set volume. Whereas a gas, the particles are moving faster and faster and faster, and the particles are moving so fast they can actually move throughout the container. Hi, I'm Mr. Franklin, and today I want to show you the difference between solids and liquids and gases by drawing microscopic representations. Basically what I'm going to do is we're going to look at H2O. Solid is ice, H2O is water, H2O is a gas. And we're going to do that by drawing a picture of what H2O is. H2O is water, and it's made up of 2 hydrogens and 1 oxygen. So I like to pick a shape for hydrogen. And in this case, let's use circles for hydrogen. So I got 2 hydrogens, and I'm going to draw circles, and then the oxygen, I'm going to use a box for oxygen. Okay? So, and if you want to label it, that's hydrogen, and that's oxygen. And if you want to add eyes to your Mickey Mouse face and a little smiley face, you can. Okay? But we've got 2 atoms of hydrogen chemically connected to 1 atom of oxygen, which is the smallest part of a compound, a molecule of water. Now it's ice. Now solids maintain their shape. So if I were to draw this, let's say this is an ice cube, okay? And I were to stack some ice cubes in here, it would do this. They would stack up, and I'm leaving some space between them just so we can tell that they're separate molecules when they would be sitting on top of each other. But I'm doing that so we can see the difference between each individual shape. But if I poured those in there, it would just pile up like a bunch of sand or something like that. The ice cubes would just pile up in this middle. It would maintain whatever shape they were in when they came in here, and they would maintain whatever volume they had. Okay, so our volume is 6 pieces of water, and it takes that shape, and it stays in that shape. I take this and I dump it out, the shape of these is going to stay the same. But now I'm going to heat this up, and I'm going to turn it into water. Now, these particles are actually moving back and forth so slowly and with so little movement you can't even see it. Okay? But as I heat it up, I cause these particles to move even faster. And as they move faster, we get a liquid, which fills the volume of the container. Okay? Or not fills the volume of the container, my bad. It takes the shape of the container, but it maintains the same volume. Yeah, you see the mouse? Daniela sees the mouse. Okay. But as we heat it up, those particles move so that they can spread out and they're moving. That's why liquid pours, is because those molecules are moving in there. Okay? So these particles are moving. It can take the shape of the container, but notice our volume is the same volume as if we poured it out, it's the same volume. If we change containers, if we change it to a Texas-shaped container, it would take the shape of Texas, and it would maintain this same volume. Let's say it was 10 milliliters. It would stay at 10 milliliters. This one would stay at 10 milliliters if that was its volume, which ice actually is unusual because its volume would be larger, 12 milliliters. Okay? But the volume for ice, if I poured it out, it would stay that volume, and the shape would stay the same shape. This one, if I poured it out, volume would stay the same, and it would change shape to match the container. Now, if I were to take this and I heat it up and I start boiling it, what happens is these start moving fast enough that they can escape, and we get a gas, and the particles spread out to fill the container. Okay? So the particles are very spread out. It takes the entire volume of the container. So if this container was 20 liters, it would fill the 20 liters of this container. And these particles are moving very fast. Okay? Very fast, so this is generally hotter or warmer. Okay? So, solids. Very little motion when they start. Maintain their shape, constant volume. Pour it into a different container. It would still be in ice cubes even though it was a Texas-shaped container. Liquid. Stay 10 milliliters no matter what you poured it into. If you had 30 milliliters, it would stay 30 milliliters. But it would change shape to match the container. This one would match the shape of the container. So if you had like a Texas-shaped gas cylinder or Texas-shaped balloon, it would take that shape, but it would fill the entire container. Okay, so what I want you to do, real quickly, is I want you to practice trying to draw what a solid of iron, a liquid of iron, and a iron as a gas might look like. So the only help I'm going to give you right now is what shape should we pick for iron? You can pick any shape. You can use a triangle, you can use you could use the square again if you wanted to. I'm going to use, because the iron filings we used were filled in circles, I'm just going to use a filled in circle. Okay? But that's my iron. Iron is an element, single atom. So now what would it look like as a solid? Take a moment and draw it. Okay? Hopefully as you pour it into the container, you might get something like this where it stacks up. Or if you even melt it into a brick, it would stay as a brick, but the iron maintains its constant shape. It also, if you poured in 10 pieces, you would keep the 10 pieces that you had in there. Okay? What's the motion of these? Is it moving? Yeah, just a little bit. Barely moving. Okay? Now, I heat it up and those particles start moving more. What would it look like as a liquid? Go ahead and take a moment and draw it. If you need to, you can pause the video while you're drawing. Okay, so my liquid takes the shape of the container. The particles are moving more. Okay, I heat it up. I get these particles really moving. What's the iron going to look like as a gas? You draw it and I will check it in your notes when I do your note check. Okay, so iron has a little bit of motion. Okay, now that you've drawn your iron, you have iron as a liquid, takes the shape of its container, has a constant volume, and the particles are moving faster than over here. I want you to draw what iron might look like as a gas, and I will check it in your notes. Thank you and have a good day.